In his first lecture, Arthur Benjamin points out an interesting fact. If we multiply by 11, our ones digit will be the same as the number we're multiplying, and our hundreds digit will be the same. And then the middle digit, the tens digit, will equal the sum of those two digits. So 23 times 11 will be 2, and then 2 plus 3 is 5, and 3, 253. Similarly, 45 times 11, we'll see 4 hundreds and 5 ones, and the middle digit will be 4 plus 5, we'll see 9, so it'll be 495. Why does this happen? Okay. I'd like you to try and figure this out. We'll look at a Montessori material that will help us, and we'll also look at what happens if the two digits, for example 4 and 7, are bigger than 9, what happens. So we're going to think perhaps that we get a 4 and a 7 on the outside, but when we get 4 and 7 in the middle, it's too big. We can't have a digit that means 11, so we're going to get 500, and then we'll have 517. Why is this? Here we have the checkerboard set up. We're multiplying 36 by 11. So we're multiplying 3 tens and 6 ones by 1 10 and 1 1. And when we look at our board, we see we're used the Montessori colors. So this square has the ones by ones. It's in green, it gives us ones. This square has tens by tens, it gives us hundreds. So in this case, we have 30 times 10. So 3 ones times 3 tens times 1 10 gives us 3 hundreds. What about the tens? How do we get tens? Well, we get 3 tens times a 1 gives us 3 tens. 6 ones times a 10 gives us 6 tens. So altogether we get 3 plus 6 tens. So we get 3 hundreds, 9 tens, and 6 ones. What about when the two digits, for in this case 79, 7 plus 9 is more than 9? What happens when we multiply by 11? So as before, the units 9 and 1 give us 9 ones. The 7s tens times 1 10, 70 times 10 gives us 7 hundreds. But what about our tens in this case? So we have our 7 10, 70 times 1 gives us 7 tens. Our 9 ones times 10 gives us 9 tens. We're going to add those two together. So how many tens do we get altogether? We get 7 plus 9, we get 16 tens. So as you recall, we slide the tens together when we're using the checkerboard. So we get our 9 plus 7, we get 16 tens. But we're going to change that into an extra 100. So we'll have just 6 tens there. And we'll have 7 plus 1, we'll have 800. So we'll get 869 from this. Try and figure out and explain in your own words why this multiplying by 11 works. We'll be using it in the first lecture. And then put this note into the Evernote notebook that you're creating. Make up your own problems to practice with. In particular, see if the same idea holds for 3-digit numbers, or even 4-digit numbers. What can you try? What can you figure out from this?